forthcoming session. We look forward for a session titled May the Force Be With You. As space exploration continues to advance, the development of more efficient and reliable energies, engines, thrusters, fuels, and propulsion systems will be critical for enabling new missions and pushing the boundaries of human exploration in space. I would like to invite our chair and moderator for the session, Mr. A.P. Baiju, Group Head, HSFG-LP, ISRO. Can we have a round of applause, please? Very welcome, sir. Our speakers for the day for the session would be Dr. Arindrajit Chowdhury, CEO, Inspecity, and Professor, Indian Institute of Technology, Bombay. Mr. Prashanth Sharma, co-founder, EtherealX. Mr. Tushar Jadhav, co-founder, Manastu Space. And we would be having two discussions and two sessions together. The later part of the session would be on the topic Launch Business Marketing Dynamics. That will be chaired by Mr. V.S. Hegre, FMR CMD, Antrix Corporation Limited, and FMR Scientist Secretary, ISRO. Very welcome, sir. Our speakers would be Mr. Dmitry Lokustov, Director General, JSC Commerce, Mr. Thomas Carroll, Manager Business Development, Space Logistics LLC, Mr. Manu J. Nair, Co-founder and CEO, EtherealX. Can we have a round of applause, please? I will leave the dais to Mr. Chair, A.P. Baiju, please. Thank you, sir. Thank you.
Hello. Good morning to all of you. Actually, today it is very happy to get introduced by the introducer. And here, it is now we are talking about the privatization, economy, all those things. Now, I would like to give a background for the current performance by the ISRO, and from where we will stretch our discussion. So I would like to patiently listen for a presentation, and then we will go ahead with your permission. So when we are talking about the propulsion, there are actually launch vehicle propulsion as well as the satellite propulsion. Launch vehicle propulsion is a launch vehicle propulsion is a high energy propulsion, whereas satellite propulsion is a low energy but a long duration propulsion. And this is the actually vision of our space founder, the Dr. Vikram Sarabhai, providing space-based technologies for the benefit of the common man. And this only I just started. The launch vehicle propulsion is there as well as the satellite propulsion is there. Just we will see what is the power of propulsion. You can see a car which is roughly 100 horsepower, locomotive 3000 to 4000 horsepower, and aircraft it is 60,000 horsepower. When it comes to a 3 engine configuration, 37 million horsepower is the power. So accordingly the velocity also it is higher, car 80, and here it is injection velocity of 37,000. And now we are coming to what kind of variety of propulsions are available in front of us right now. It is stored gas system, chemical system, electric propulsion, and advanced propulsion like nuclear, solar, etc. In the chemical itself, we have solid propulsion, liquid, and hybrid. And the name itself, it reveals whether the solid, liquid, and hybrid. In the liquid itself, it is air storable, cryogenic, and semi-cryogenic. And coming to the solid, the advantage is it is very simple, but only limitation is it is not restartable. So multiple start is not possible, and the performance is relatively low, 275 seconds. It is the ISP, which is an index of its propulsive quality. And liquid engine, when we are coming, it is restartable, but it bit complex. but it is the performance is as high as 460 seconds ISP. When coming to cold gas, it is relatively a low thrust propulsion, which is having restartable, but 270 second only maximum is possible. When coming to electric propulsion, it is restartable, controllable, complex, but the highest, the ever highest ISP, 10,000 up to 10,000 seconds we are getting, but the limitation is very low thrust. But it can be run for years or more. So that much of capability is there. When coming to nuclear, it is restartable, controllable, etc. But it is hazardous, but only it can be used in outer space. And coming to, just to flash over a solid propulsion, it is the loading, 1 kg loading to 200 ton loading in GSLV Mark III solid propulsion, it is there. And liquid engine is first earth storable propulsion. Earth storable, the propellant is UDMH and N2O4, fuel and oxidizer. And MMH N2O4 is also combination is there. We have ISRO 1 Newton to 800 kilonewton level of thrust. Monopropellant, bipropellant, and bipropellant pump fed is the highest thrust engine. And when we come to cryogenic engine, we have 7.5 ton thrust, 20 ton thrust, which is used in Mark III LVM3 vehicle, and semi-cryogenic engine, which is having a thrust of 200 ton, which is actually under the development. And you can see the cryogenic engine, when we are testing in the ground, the
1, 0,
we will see one video
2,
of a ground
3,
test.
4, 5, plus 10 seconds, plus 15 seconds,
and similarly, the tanks are insulated because it is kept under low temperature. So the temperature heat transfer into the propellant through the tank wall will give a actually vaporization of the propellant, and it will not be used, it cannot be used for the propulsion. So next we are coming to how a pump fed engine, liquid engine is working. We can see 2 oxidizer and fuel pumps. It will pressurize the pump, fuel and oxidizer, and injected into the chamber. A small percentage is burnt in a gas generator, which drives the turbine, turbine, and which in turn is the prime mover for the pumps. And when we go to the regenerative cooling, high thrust cryogenic or semi-cryogenic engine, one of the fuel itself is used as the coolant, which runs through the outer periphery of the shell, and it gets injected into the chamber. So here we have a definite analysis capability, external aerodynamic analysis, as well as the combustion and modeling of internal combustion as well as expansion in the nozzle. So this kind of tools we are using for the design and analysis of the vehicle. And here you can see earth storable engines we are using for PSLV, as well as the LVM3 for the high thrust twin engines are used in a single stage, L110 stage. And similarly, cryo propulsion is used for the GSLV Mark II vehicle as well as for the Mark III vehicle. And a lot of facilities are parallelly developed along with the development of the vehicle. And the current trend is semi-cryogenic stage, which is having a ISP in between the earth storable engine and cryo engine. But the advantage is its density is higher. So that is giving a higher loading and a higher thrust for the lower stage engines. And by using a semi-cryogenic engine plus a uprated C25 engine, we can go from Mark III 4 ton to GTO to 5.1 ton to GTO. That much of payload advantage we are getting. And the well-proven LVM3 or GSLV Mark III vehicle we are using for the current development of ISRO, that is Gaganyaan mission, which is going to be in 2024 and 25. And first two will be unmanned missions. There, in the place of satellite, we are using crew module and service module together, which is kept inside a crew escape system. The crew escape system will be used only if some anomaly is found during the launch vehicle. Launching the vehicle is going through the profile. So whereas coming to the, you can see if there is no problem, the launch vehicle will carry the crew module to the orbit, and which will be rotating in the low Earth orbit 400 by 400. And there, after 3 days, the crew module will be brought back to the Earth with the help of small thrusters and parachute. And here also you can see the main challenges are how to reach orbit, how to use the zero gravity, how to cope up with the zero gravity, and how to reach back safely to Earth. So you can see some of the crew training methods, because to encounter with the zero gravity, this kind of exercise have been given to the crews. And coming to now, the latest technology is clustering of one developed qualified engine, so that any thrust can be achieved, replacing the solid or the like our Falcon or the Elon Musk rockets. Now they are using Raptor engine for the 33 Raptor engines they are using for the first stage, and then the same engine they are at a lower area ratio, higher area ratio they are using in the second stage also. So LOX methane engine, that is the current art of technology. The LOX methane means advantage is methane is performance better than kerosene engine and lower than the hydrogen engine, but methane is cheaper than hydrogen, and methane is available at different planets also. So that way we are methane is given the preference in the liquid engine propulsion. And the another strategy is to recover these stages once the launch vehicle can be some of the, at least some percentage of launch vehicle cost can be reimbursed. And hybrid rocket engine, taking the advantage of liquid engine and limiting the disadvantage of solid engine, we are using hybrid engine. And nuclear engine is also we are using, but here the uranium is the propellant, and with which decay the hydrogen will be heated and expanded through a nozzle, and the thrust will be produced. But here also the launch vehicle, the usage thrust is limited, and only deep space exploration, the nuclear propulsion is basically used. And one more thing is technology for the future. Actually, we need improvement in the materials like a composite tank and materials with the epoxy resin to reduce the weight of the propellant so that the payload weight can be reduced. And additive manufacturing, normally called as 3D printing, is also another way to increase the production rate. And coming back to spacecraft propulsion, there are mainly orbit racing, orbit maneuvering, etc. Interplanetary missions and deep space missions are possible, but here the low thrust but a long duration propulsion is used. So here the main advantage is the thrust required is less, but the ISP we require more. So here in earlier, so far or earlier to some 10 years back up to, we are using only chemical propulsion, but now electric propulsion has slowly replacing the chemical propulsion, and other propulsion also we have like nuclear, solar, tether, etc. So here the advantage is higher performance. It will give longer deep space exploration is possible very much. And here and thrust required is only millinewton. So we have both monopropellant propulsion as well as bipropellant propulsion for in the chemical area, and we have electric propulsion also developed in ISRO. Electric propulsion advantage is the 5.5 ton, a conventional chemical propellant satellite can be reduced to 3.5 ton. You know the launch cost is in terms of per kg, say $4,000, etc. So that when you are reducing the payload weight, that much gain we will be getting. And coming back to green propulsion is also another modern propulsion we are thinking of, in which bipropellant as well as monopropellant, like hydrogen peroxide or hydrogen peroxide, ethanol, or kerosene combination also we are using. And coming back to liquid engines developed from 1 millinewton, like MEMS propulsion, to 2000 kilonewton engines. Liquid engines are being made in ISRO, and we are propelling it for the different purposes. Similarly, the stage is also 1.6 ton to 120 ton, up to semi-cryo also we are in the area. And coming as a forward direction, the future, the 2024 to 27 as well as 30, we have LOX methane engine and MEMS propulsion and high thrust heavy lift launch vehicles, etc. are there in our plan. And we will have a good future in this session, because now private players are also coming to in our business, so that we will discuss further on that. Only one thing, this year and next year, 2 unmanned missions will be launched from our land. So after that, 1 man mission, humans in space, will be launched. Our dream also, I am just sharing with you. With this, I'll stop. We'll just see the video. The atmosphere is the toughest time, because high heat flux is there because of the atmospheric entry. So we have to have a very strong insulation, like tiles and silica phenolic material is required to protect the system, because humans are inside. So we have to give a care, care has to be taken for the development of this crew module. And with the parachute help, we are getting back to the sea, and that will be with the small thrusters also will be there to reduce the speed. So with this, I ask our IIT Professor Bombay to continue. Okay, what type of contribution and evolvement can be there with the private players into this a mega game?
All right. Am I audible? Yeah. All right. Very good afternoon to all of you. How long do I have roughly? 5 minutes. All right. I will start with a very interesting tidbit about people who are in propulsion. So next to me is Mr. AP Baiju. He is into propulsion in ISRO. Out of DRDO, the person who is heading HEMRL is Mr. AP Dash. And out of HEMRL, that is out of HEMRL, out of DRDO. Out of DRDL is Mr. A.P. Vardhan, who has been instrumental in developing their, the propulsion technology. All of them share AP, which stands for ammonium perchlorate, which is again a workhorse propellant for most rockets. I find it very, it's a case study that I'm doing. How many more AP people are there in this area? That aside, so I'm Arin. I'm out of IIT Bombay. I have been there for about 13 years now, and I study propulsion, I study combustion, and this has been my area of expertise as well as passion for a very long time. So recently, me and my co-founder Tausif, we opened a startup called Inspecity. We dreamt as big as possible, which is about building cities in space. But we realized that to gather funding for doing that, to convince both ISRO, defense, as well as the private ecosystem, it was very, very challenging. So we stepped back and we said that we want to build enabling technologies to get to that state. And that would be having some kind of automated platforms up there in space. And we figured that that has utilities in satellite servicing. So we are in the area of satellite servicing. And we also develop our own propulsion systems. And for that, as you saw, there are many, many possibilities. You can go electric, you can go chemical. From my perspective, although we listen to Mr. Baiju kind of talk about electric propulsion slowly supplanting chemical propulsion, slowly moving it away, from my perspective, it takes a really long time to kind of execute the chemical propulsion maneuvers. So it's like having a Ferrari versus having a Tata Nano, which is very, very good. And it gets you there, but it gets you there very, very slowly. If you could have the Ferrari, you would definitely go for the Ferrari. And I see a future where we have refuelable chemical propulsion, where we are able to dock with another satellite and fill it back with the fuel that it's missing out on. And that would be a very, very simple scenario where everybody has a Ferrari, okay? Same thing, if you're going to GTO, you would need about 6 months to reach there. You definitely save a couple of tons, but you take that much longer to get there. So if you had propellant depots up there in the geostationary, in the transfer orbits, you can definitely refuel your satellite and go up there. So that way, I definitely see the need of chemical propulsion in the coming years, where as a customer, you're able to deploy your satellites that much faster. So in our case, we have looked at, different types of propellants that are available, and we have chosen a combination with nitrous oxide and propene. Simply because nitrous oxide is the laughing gas, and if things go wrong, you can, at a development level, we can have a laugh at it and, get better at it. And propene is the barbecue gas, which helps us in cooking on a regular basis and having parties in the team, time to time. But that aside, it's a very, very safe combination, very, very reliable combination, and because it's a bipropellant, it trumps the monopropellants in terms of the specific impulses that they have. Specific impulses, like, because you're in this area, I'm assuming you know specific impulse, which is like the mileage of a car. So that is the combination that we are developing. We want to use it in-house. We want to talk to ISRO to see, how can we use that in order to fulfill their necessities instead of using this a carcinogenic propellants that is being used now. How to qualify, how to make it useful for them. As a propellant, let's say development, I do see there is a lot of force in today's world in terms of coming to a state where we want to standardize the propellants that are being used. There are a lot of propellants that are being floated around. There are companies coming every day, not let me say every day, every other month in order to come up with newer and newer ways of propel satellites in space. But I think we also need to keep in mind that we want to go towards a state which is kind of standardized over a period of time. And companies need to kind of come together and analyze what kind of situation would that be. So I would kind of encourage everybody to think along those lines. Safety is a major issue when you're working with propulsion that I would want to stress for us, ourselves, as well as companies that are working in this area that are coming into the picture. I would say that you need to have facilities that are always operated remotely, that have no lacunae in terms of safety measures that you are taking. That is one area that should be very, very critical. Protocols to qualify the thrusters or qualify propulsion systems should be carefully looked at, and ISRO can help a lot in terms of getting to those qualifying protocols that would be there. There are a lot of areas to talk about, but let me pass on the mic to Prashanth and see where we go.
Hi everyone. So I am Prashanth Sharma. I am representing EtherealX here. So as sir in his PPT shows that we have a variety of launch vehicles. We at EtherealX are also working on India's most powerful partially reusable and fully reusable launch vehicle. We will be capable of taking 24.8 tons to LEO in expendable configuration and 22.8 tons to LEO in partially reusable configuration and 8 tons to LEO in fully reusable configuration. So as you saw, in liquid also there were earth storable, cryogenic, semi-cryogenic. We followed the path of semi-cryogenic. So we are using RP1 and LOX, like ISRO seen equivalent of RP1 in India and LOX. I saw that ISRO has planned for LOX methane engines. So there was one question from my side to you. So what do you think will be a perfect operating cycle for a LOX methane engine? Because I saw that the SCE 200, it was giving ISP of 335 with LOX and ISRO scene. So if we are going with LOX methane in GG cycle or stage combustion cycle, there will be hardly 10-second difference in ISP. So what do you think?
No, I will say like this. Okay, there is a shortcut to go for a higher performance, and there is a long way if you go for conventional. But at present moment, I am not supposed to reveal the engine cycle which ISRO is planning, because it is still under debate. But definitely we can see the LOX methane Raptor engine is by our Elon Musk team, that is fully staged combustion cycle.
So actually at EtherealX we have developed one new combustion cycle. So how we are achieving full reusability. So our second stage actually.
What I heard is it is a combination of JG cycle and what I heard yesterday, Mr. Manu was telling, it is a combination of GG cycle and taking the benefits of all the cycle. You are developed a third cycle, which is the best right now. Yeah, good luck.
Thank you. So
Just one more. The main problem is when you are going for staged combustion cycle, that means the entire propellant is burned first. In the first combustion is in a pre-burner, and second combustion in the thrust chamber. Now, in this methane mode of combustion, the combustion instability is a problem. We are also facing in ISRO. So, how to come out of that? If it is a GG cycle, the benefit is you can separately test all the systems. That GG is a choked condition, GG is performing. So you can do a nozzle, put a nozzle, and you can completely study the combustion dynamics of the pre-burner. Turbo pump, you can separately test with water. Then with water, you join GG and turbo pump together and assess the performance. And then later, thrust chamber also you can do separately. So that mode only we have developed a CE20 engine, and to proudly say that the first flight of ISRO of LVM3 or Mark 3 was a success because of the simplicity. So that credit at that time, Mr. Madhav Nair was the chairman of ISRO. So full credit is to him. So that way, simple way, but slightly it will be, it will have, okay, people may say, okay, ISP is less by 10 seconds, but no problem. One failure will keep you away from the business sometimes. That can be catastrophic. So private team, I suggest instead of performance, your commercial it is also has to be successful. So for which 10-second ISP is not a problem. You go ahead in a safe mode. Otherwise, one failure will send you back by 2 or 3 years.
So keeping that in mind, we chose RP1 and LOX. Like we don't want to do too many things that are new to India. That's why we went with RP1 and LOX. This has been our expertise, and working at Manastu, we have seen it.
Only 10-second difference between methane and RP1. That's not an issue.
Another thing I want to touch, like Arindrajit sir said, ki safety is a very big factor. So all three of us at a point of time was part of Manastu team. We have seen heaters exploding while we were doing thruster testings. Tushar has been through an injury because of propulsion systems. I have been through an injury because of propulsion systems. So safety is definitely one of the part that many young startups don't know what safety protocol there is to follow until they mess up very bad. So I think ISRO should also help in safety regulations, like policy is coming up. So these are the safety regulations for engine testing. If you don't qualify this, you can't test your engine. Something like that.
Safety rules and regulations are actually being developed by the immense experience. So earlier, even USSR, that time, lot of safety issues were there. Even 40 people together, okay, some mishap happened. So that way, if you see, nowadays it is less because that based on the Russian experience and that those things are revealed of late. Maybe after 30 or 40 years only Russia has revealed it. So that way, we are also going very safely. But definitely, when you are taking some challenges, some safety issues also will be there. If you are only conventional thing, if you are going that way, so it is a trade-off only.
So I'll pass the mic now to Tushar.
Yeah. Thank you, sir. Thank you for this opportunity. So we are Manastu Space, and we are building green propulsion system for satellites. So before I'll get into more detail about what we do, why we do is very important for us. The story of Manastu started well before actually Manastu started. We were a student in IIT Bombay, and as a student, we built a student satellite called Pratham. And one of the application was to get the early warning of a tsunami. So idea was when the tsunami happens in the ocean, when the earthquake happens in the ocean, the wave, the disturbances travel to the surface of the ocean, and then from that it travels to the shore. And then the same disturbances get transmitted to atmosphere and then ionosphere also. So our satellite was monitoring that ionosphere. So if we can see, and people have seen in the history that we have a very significant differences in the free ions on the ionosphere because of the changes triggered through this earthquake and then the waves that generated in the air which has traveled into the ionosphere. So idea was, can we demonstrate that technology and which can go into the big scale? And we were student, we were interested in the engineering part more than the science part. So one thing led to another in 2016 that got launched. And in the whole process, we realized, this is very fascinating opportunity, space for solving the problems on the earth. And the day it got launched, it was, dream came true. It was October sky moment for us. And that's when we realized our passion. So this purpose and passion put together is we started Manastu Space. So this space, which has a lot of benefits, can we keep that sustainable? If you see in the verticals, 7 verticals that Euro consultant director was talking about, the sustainability is one aspect of it. And that's where the green propulsion system and other technologies that some of them Arin sir touched about in terms of sustainability by refueling the satellite, by extending the life of a satellite, they're doing the similar technologies on that. Right? So in terms of sustainability, currently the fuel that goes into even ISRO uses a lot of ways is the hydrazine. And we talked to a lot of people on the ISRO and also in the DRDO side, that's extremely toxic, carcinogenic. So, and the world is, looking for the better alternative to hydrazine, at least for the satellite application. The launch vehicle, what are some of the applications that ISRO uses, still far, but the main satellite wise, and a lot of international regulations are coming up. They're phasing out the hydrazine in the satellite. And a lot of launch vehicles are saying we'll not launch a satellite if it is as a hydrazine on top of it, and they don't have the facilities to operate the hydrazine, fill it, and all those operations. So in all, we see the lot of gap in that. And thankfully, we came up with a solution where we started with hydrogen peroxide, which was used in World War II time. And then it got phased out because of lesser performance. So then we came up with additives into hydrogen peroxide, and thanks to the developed materials and the processes around it, we stabilize the hydrogen peroxide and we increase the performance of the hydrogen peroxide so that the problems that we had earlier of low performance get solved. And on top of that, we make it even better. And of course, we make it very stable because using the materials such that it has a shelf life of say 5 years and then the thrusters around it, and the materials, high temperature catalyst material around it. So we have developed this whole system in-house. Currently, we are in the testing phase. So idea is can we replace this propulsion system in the satellite with the green propulsion system, and hydrogen peroxide being readily available, we can reduce the cost significantly of that. So, and then starting after that, once the fuel is propulsion system is built, what was the next as a part of a sustainability, as a core why of us? So we said we saw our Pratham satellite, after some time it was defunct and it is now junk. So, and the junk problem is becoming a big way. So can we make this propulsion system an autonomous and use it as an autonomous collision avoidance system? So like what has in the aircraft, so that what the constellations can use benefits it in a big way. And then after the fuel of the satellite is over, can we refuel the satellite, and can we deorbit the satellite? So these are some of the plans that we are building on around the propulsion system as a core, with a very strong point that we are working with the satellite potential customers from the day zero of the development cycle and till the end of life, the deorbiting of the satellite. So whole services and the products are around the satellites and the life of the satellite. So coming to some of the new technologies that is happening. So nuclear can be a very interesting, if in the deep space mission we're looking very interested, and I'm big fan of nuclear on the ground also. More power to nuclear power.
Space missions, actually nuclear only is the feasible thing, because when you go out of the solar, solar energy is not available. So only nuclear for a longer this thing. So one day or other we have to succeed in that nuclear propulsion. So we are happy to know that you are also interested.
Yes. So as a scientist and physicist in me, definitely rooting for nuclear. As a businessman in me, I will take some time before I can think of putting in dollar to that. So always happy to look for research about and see the news. The NASA, DARPA is collectively very, very interested in the nuclear, and we believe that has a multiple application, because it's an energy source. You use that energy for whatever way you want. You want to heat the hydrogen atom or helium atom, whatever works out well, and then exhaust it as a propulsion system, or you use that energy and whatever form you can. And that's exactly the problem we are solving it on the ground. So one of that classical case of technology that has been developed in the space or for the defense application coming into the civilian application, say 5 year, 10 year, 15 year down the line, we are seeing that technology similar way can become a very integral part of small modular reactor, which has become already a very interesting business case for the ground energy thing. So we are seeing it in a big picture point of view, considering the propulsion being a part of energy. That energy maybe in the space or on the ground, doesn't matter. Technology can be same or similar. So that's how we see it, and very interesting things happening, particularly in India. Building in India for the world has been a focus for us, and thanks to the leadership in India, the geopolitical situation of India, we sat at the junction where it's a high time we don't miss out the space bus. So and the services and the products around it, and that can give us a lot of geopolitical leverage also, and that can help in the upskilling the high-end high-end technical skills of the country. So that is what we are, and that is what we are looking to do. Thank you so much.
Hi everyone, good afternoon. This is Manu from EtherealX. I think.
Okay, you are member of next session. So to conclude, actually the.
Sorry, I can't talk about propulsion. I'm not cleared to.
So
glad I'm not asked about propulsion, because I can't speak about propulsion publicly.
Thank you, gentlemen. Thank you, distinguished panel. I'll request the panelists to stand for the group photograph, please.
Do we take some questions?
Okay.
One or two questions also.
Sure.
Yeah, please shoot one or two questions, sir, so that your curiosity also can be fulfilled to some extent.
Do we have any questions from the audience for the session? May the force be with you for the panelists here to answer.
How long will hydrazine be a lady choice?
No, hydrazine, the main problem is shelf life. As time goes, the decay is happening. So hydrazine will not be a choice for long.
The name begins with Hydra. When you cut off one head, it has 7 heads. You cut off one head and two more spring up there.
Yeah.
It's very hard to get rid of hydrazine. Right.
If you asked me yesterday.
Okay, only one more thing I would like to add is, earlier Ambassador and only Tata vehicle or somewhere we have stuck up. But okay, after that we have seen that a lot of vehicles, even Corolla, all vehicles are available in India. So I am giving a clue to the private teams that you need not work behind ISRO. You take up things from the external sources and compete with ISRO. That is my advice.
Thank you, panelists. Thank you, Chair. I will take 2 minutes to make adjustments for the next session, please. Kindly allow us 2 minutes here. Yeah.
Safe word. Tell the guy not to do for barbecues. Barbecues in space. Rotating the spacecraft.